Assalamu alaikum. Students, today we are learning the embedded system. And as you can see, the definition is a combination of hardware and software. And this combination is needed to carry out a certain task. The hardware can be electronic device, the hardware can be electrical device, or the hardware can be electromechanical device. Now, what is it based on? You can see it is based on any of the three components that I mentioned below. It can be a microcontroller, it can be a microprocessor, or it can be a system on chip. What is microprocessor? We already are aware of because we have been talking about the same from the beginning. It's an integrated circuit which has CPU as on the chip, and there's no RAM, ROM, or peripherals that are present on that integrated circuit. On the contrary, if you see the microcontrollers, they have a CPU in addition to RAM and ROM, and all other peripherals are also embedded onto one single chip, and they are made to carry out a simple task, a specific task. And the last one, system on chip, which is abbreviated as SoC, it is going to contain a microcontroller as well as if its components. And it is containing, they almost always will include a CPU, memory, input, output, and ports, and the secondary storage as well on the same microprocessor chip. So this is the basic thing that we need to know in order to understand what is an embedded system. I hope it's very much clear to all of you. Now, the next thing is, what is an embedded system? Looking like, or you can say it's going to be summarized in this figure. As you can see, software and hardware on an embedded system, they need a user interface, and you are already aware what user interface is. And definitely it is going to take some input or output, and the input or output can be in analog or digital form. After that, input will be processed, that will be given as output, and you can see some of a form of output will be there. So user interface is needed to connect with the embedded system, and definitely there are feedback. And if you recall, feedback means we have talked about this feedback when we were learning our monitoring and control system. So the feedback is also an important component of our embedded system. Installed in a device, either an operator can input data manually, for example, select a temperature from a keypad, or turn a dial on an oven control panel, or the data will come automatically. So this is what you can see here. The input can be in two ways. Either the input is given by the user, or the input is going to come automatically with the help of some of the you can say some of the sensors. Sensor readings are also going to be taken. This sensor input will be analog or digital in nature. For example, inputs such as oxygen levels or fuel pressure in a car's engine management system. Output will then carry out the function of the embedded system by sending signals to the components that are being controlled. For example, increase the power to the heating elements, or an oven to reduce fuel levels in the engine. And this is your outcome. Or I can say the impact of whatever has been done will be resulted in this output. Now, what you can see here is the applications that are being discussed here, that what are the applications of an embedded system. As you can see, they're programmable or non-programmable. So you just go through it very simple. Connecting the device to a computer and allowing the download of updates to the software. For example, this is to be, as far as upgrading is concerned, it is done in two ways. Either you are going to connect it to the computer and the downloading will take place, or automatic updates via a Wi-Fi. So these are the two alternate methods that are available for updating the system. One more important thing that you need to know is the benefit and drawbacks of the devices that are containing the embedded system. As you can see, the benefits are they are small in device sizes, and that is why they are easy to be fitted. Compared to other devices, they are relatively low cost to be made. They're usually dedicated to one task and allowing simple interfaces and often no requirement for an operating system. Here, they are performing one single task. That is why there is no need of an operating system in this environment. They consume very little power. They can be controlled remotely using a mobile phone, for example. Very fast reaction to changing input operation. With mass production, it comes reliability. And that is one of the key features, that once you are producing the items in bulk, then definitely the cost is going to be reduced remarkably. What are the drawbacks? It can be difficult to upgrade some devices to take advantage of the new technology. Troubleshooting faults is definitely going to be a difficult task because not everyone can troubleshoot the problems. Although the interface appears to be more simple, for example, a single knob in reality can be more confusing. For example, changing the time on a cooker clock can require several steps. I mean, those steps may not be easily handled by the people who are not very happy with the computer, with the use of computer. Any device that can be accessed over the internet is also definitely open to hackers, and that is one of the biggest threats of your embedded system. Due to the difficulty in upgrading and fault finding, devices are often just thrown away rather than being repaired. And that is definitely going to result in increasing the carbon footprint. Can lead to an increase in the throwaway society if devices are discarded just because they have become out of date. I mean, this happens quite often. If we keep on throwing the stuff, you're not recycling, that results in a lot of problems. And that is one of the biggest drawbacks of your embedded system. Now, this, I hope that was very much clear to you. Now, one more important thing that we need to understand and remember is that embedded systems are connected to the internet, and that is why it is possible that you can handle it, you can control these devices remotely using a smartphone or even a computer system. And that is, example is mentioned here that we can set the central heating system to be switched on or off as per requirement when we are away from home. Like maybe I am on a you can say trip, and before I want to reach home, I want my central heating system to work. I can handle it if it's embedded, if it's using an embedded system. I can remotely monitor it. I can remotely make it work. Since embedded systems are dedicated to a specific task, the engineers are optimizing their designs to reduce the physical size. Now, what is the job of the engineers? What they are trying to do is definitely in decreasing their size is going to result in can say performing a little better, and that is what the engineers are working on, to reduce the physical sizes so that the cost is going to be reduced as well. The range of applications are vast, ranging from a single microcontroller, for example, in an MP3 player, to a complex array of multiple units, for example, in a medical imaging system. So these are the simple applications that are being discussed here. So what we need to know is the definition of an embedded system, the pros and cons of embedded system, and the examples. If you just go through these examples, they are very simple that you can just read and you can understand very easily what is the use of embedded system in motor vehicles. And you can see with the help of the diagram, the use of different devices here, that are being mentioned. The first thing that is being mentioned is a set-top box using an embedded system to allow, for example, recording and playback of television programs. And this can be operated remotely by the user when not at home, using an internet-enabled device, or by using the interface panel when you are at home. Now, embedded system will look after many of the functions involving input from a number of sources, such as an SSD, where television programs can be stored or retrieved, or a satellite signal, where it can be necessary to decode the incoming signal. So what you can see here is the use of an embedded system in different situations. As one, and another example is mentioned, that is the security system. So although we have been talking about security system earlier under the heading of sensors, so here it is being discussed once again under the heading of an embedded system. So once you go through it, you'll be again able to understand the beginning is the same, that you have the sensor inputs in the form of temperature sensor, pressure sensor, and acoustic sensor. And then there is a security system controller, which is getting the interface. Yeah, definitely it's a keypad input as well, which can be a keypad input as well. And after that, we have the storage in SSD, and definitely the role of RAM is also being discussed here, and that is the chain that you can see. And definitely the output will be given to you, but because once anything is being compared, the feedback is there, so definitely the output will be given as well. Another discussion is regarding lighting system. And if you recall, this is what we have already discussed under the heading of our sensors. That the sensors are being turned, or the sensors are going to take the light input, this in light intensity level. And based on the input given, it will be deciding that what is going to be the decision to turn on the lights or to turn off the lights. So something similar to this one we have already discussed. One thing that is new to you is the vending machine. Vending systems are going to be a little bit, you can say, maybe you have seen those machines. They usually may use microcontrollers to control a number of functions that we all are associating with the use of these vending machines. What you can see here is a microcontroller is there, and this microcontroller is getting a few inputs that you can see, input page to make the selection. Input pad is there that is used to make the selection. Sensors are there to show the position. We can have the counter to ensure the correct money is being entered. And then we have temperature sensor to help maintain the correct environment for the items, because definitely vending machine is going to dispense whatever is it's going to work on. And then we have the different use of sensors which are being there to work on actuators, the role of actuators. is going to be there to control the motors that are going to dispense items, and definitely you can see the actuator's role cannot be eliminated. Display is going to be there to tell the people about the prices and other stuff, and wireless modem is also going to be there to send the data back to the machine vending operators. So this is just something that is new to you, but otherwise all of the stuff that is being discussed here is what you have or have already studied about. Moving on to the next thing, we have the discussion of our at the heart of the vending machine. So you can see this is the same discussion that is being given to you. And washing machine. By the way, if you talk about washing machine, we have been discussing about the washing machine's use as far as the simple instructions are being given. If you remember, we have talked about this topic under the heading of RAM and ROM. The instructions are being present in, some instructions are present by the manufacturer. They are entered by the manufacturer, which are present in the ROM, and the other instructions are present in the ROM, which are written by the user, which are given by the user. So same case is going to be discussed here under the heading of embedded system. So this topic is very simple. You can comprehend this very well. You can work on it very well. And already we have covered some part of it. So I hope that you will be able to understand and work on it. Okay. Thank you very much. Best of luck. Allah Hafiz.